Yeah, I
Thank
was
you.
like, that
How
across.
that I know. That feels like already the situation I'm in in real life.
Cheers.
Cheers.
Hey guys, welcome to the Latent Space cooking series where we invite founders and researchers and just let them cook. Today we have a very special guest, the Chief Research Officer of OpenAI, Mark Chen. Welcome,
Thanks
Mark.
for inviting me, Alan.
Yeah, thank you for coming. I mean, to begin, this all started from the inspiration after hearing a story that Mark Zuckerberg would make soup to try to poach researchers. And in response, you brought soup to researchers. Is this true? Did this happen? Did it work?
Oh,
Is there more
it's
behind it?
absolutely a true story.
Okay.
And I have brought soup to our own researchers. I think that made us calm down a little bit. I think
Yeah.
we came out on top. But yeah, still a very funny story in the craziness of how AI has evolved.
How often do you cook? Is this something you're familiar with?
Well, I do enjoy cooking, but I don't have the luxury of doing that so often. So I usually have a work dinner every night of the week. And, maybe post AGI, this is going to be my hobby. I've always joked, I'm going to start a noodle stand once it's all over.
Yeah. Post AGI, hopefully that'll, still be there, but great. And I guess looking at what we have in front of us, do you have an idea generally of what we'll probably be making?
Korean tofu soup, maybe?
Yeah, that's generally what it is. So we inspired off
Okay.
of this story
Okay.
of you, bringing soup to researchers. So we're making a tofu Korean stew, and then we have prawns that we'll be cooking. Are you ready to go?
Yeah, let's do it.
Great. Okay. So the first thing we should probably do is we'll separate the veggies and then we can
Okay.
cut them. And basically what we want to do is just cut the dirty part off with the dirt and then, separate that across.
Alan, that I know.
Yeah, okay. And then just have that there. So
Okay.
we could do that. And while that's going, I guess I could ask more about your background. So in a previous life, you were once a trader. And even Sam, I think, last year in April, also tweeted about how if you're a high frequency trader, you should consider joining OpenAI because, build AGI. So do you think there's a relation between, being a trader and being a researcher, or do you think it's just like a very technical and competitive area where a lot of great employees can come from?
I think really the most important thing is there are a lot of researchers who just started out without a formal training in machine learning or AI research.
Gotcha.
We've very much believed in training people up to do this. I think the real hard thing is the ability to creatively solve problems and think outside of the box.
Yeah.
And it's not so much, you have to do a PhD, even though that does bring a valuable skill set. With trading in particular, I don't know that it's that special of a profession. I kind of think of it as, we've had great mathematicians join, we've had great, physicists join, but trading is something where, it's very unhackable. You can't kind of cheat the real world, right? It's a hard metric to optimize. And there's also a lot of characteristics it's a field where attention to detail really matters.
Yeah.
And, it's kind of the brutal hard optimization and squeezing out the juice of a system. And some of those skills transfer over.
Gotcha. Yeah. And I guess for people who want to get into research, who let's say don't have a PhD, what do you think are the main attributes or things that they can learn to develop research taste? Because I guess that's the main part of getting into this field that may be very foreign to them.
Yeah, I think it's a little bit overrated. It is something you have to develop, but the best mechanism I've found for developing that is really just replication. So I think you should take papers that you really look up to and just try to fully replicate it. I think a lot of replications stood out in my mind. Back in 2018, there was ResNet, there were pixel CNNs, and I think I learned so much just trying to replicate the training curves exactly, get to the exact amount of training loss or perplexity that the papers hinted towards. It teaches you a lot of techniques, right? That people don't really kind of talk about, but once you dive in a couple of layers deeper, you learn those techniques. And I think really the first thing too that got me into the field was when AlphaGo played Lucidol. And I think that was a turning point for so many people.
Yeah.
And it was inspirational. And the first big project that I really went after was can I get a DQN working?
Yeah, that's true. I think it was Move 37 or
Yeah,
from one of the games. It was pretty insane watching it happen and seeing all that develop and see also where we have gotten to today, especially with research.
Isn't it crazy that you're seeing Move 37s in almost every field now? It's there's Move 37s in math, there's in computer science and coding. I think just it feels like a lot of people woke up at the start of this year and were like, man, agents are working in
Yeah.
my profession, and they're essentially realizing that these models can just do long horizon, meaningful work for them.
Yeah, no, that's true. It is very impressive to see, like even just using it in my own work. But okay, the next thing we could do is just as simple, just cutting the onion.
Okay,
So what we have to do here is just like dicing it.
Yep.
Do you think there's jobs that RL maybe will have like a much harder time to kind of break into? So for example, coding may be easier since a lot of the context is accessible, whether it be the code bases or even the work you're trying to do. But let's say if you're trying to do the job that a junior consultant may do, where all the context is a little scattered, maybe a little more difficult. How do you view through like those different scenarios? Is there a way that you kind of assess what can be the right approach?
Yeah, I mean, I think RL's traditionally had headwinds when it's come to fields that, it's more kind of subjective than objective. So if you kind of think of, one kind of, example of this is creative writing, where, you can take two pieces of creative writing and two experts can have wildly different opinions.
Yeah.
So it's these fields where things are hard to grade, where RL has the least amount of ability to kind of go and directly apply there.
Yeah.
I know a lot of people are developing techniques to apply RL in these settings, but for now, it's just where there's cold hard truth, things like math and computer science, where you implement it correctly or wrong. That's where you kind of see it really taking off.
Yeah. No, that actually brings up a thought on in terms of evaluating those fields. So, as models get much more powerful and they even saturate, for example, solving like the IMO questions. How do you view evaluating like superhuman intelligence? Like get to a point where it's so good at things that even the top 0.01% of humans can do. That how can we push past that frontier of intelligence?
It's kind of crazy, and I feel like a lot of it centers on kind of interfacing with the real world. And when we've thought about how to evolve past things like programming contests in the past, I think a lot of the initial direction we took was you should move it to real world research, right? And we've seen that the models, they've gotten a lot better at just kind of discovering novel theorems and pushing the frontiers of hard sciences. But even today, right, that's no longer a surprise. I think we almost take it for granted now that these models can solve very, very difficult problems. They can make contributions and even kind of draw relationships between fields that that are novel and insightful.
Yeah.
So I think we think of coding co-working as really a domain for that tests if our models can learn in high context settings and in real world long horizon settings.
Gotcha. Okay. Yeah, that makes sense. And since you're done with all the vegetables, we can now do the next step, which is sauteing it. So
cool.
Yeah, we can use the impulse stove, which we've seen before, and it's very powerful. Let me turn it on. So we'll just saute it with some oil. So put the pan in the front burner, and then
these are cool stoves.
Yeah, you could use the oil to pour some in, and then we can also, just a good dollop, perfect. And then we could turn on the stove. So just press it, and then spin the knob. Great, perfect. And then while that heats up, we can just wait and then add the vegetables. But I guess more so on views for research, are there, I guess, commonly accepted ideas that are, you disagree with, whether it be like pre-training is dead or language models will never get us to AGI? I think there's a lot of takes out there that are very ambiguous and obviously haven't been proven out yet. And I guess from your perspective as like the research, like leading things in OpenAI, think through those.
I mean, I firmly believe in being on the exponential and in scaling laws. So I think any of these bear takes, I fairly strongly disagree with. When it comes to pre-training is dead, I think the funny thing is this narrative only started spreading more widely after, let's say, the last 1 or 2 years or so. But in many times in the history of developing LLMs, people have been saying this, right? And there have always been some bottlenecks that people, you can't scale past this because of this bottleneck. And we've always found some kind of technique, whether it be better engineering or some new research insight that helps you break past the boundary. And so I think it's just more and more of the same, right? Like more careful research engineering, more careful data engineering, more careful scaling. And it always unlocks that next ability to scale further.
Yeah.
So I mean, it's held for, almost 10 orders of magnitude, but there's no reason it should not keep holding.
Yeah, that's a very fair point.
Yeah.
And I guess on research bets that have helped you scale beyond, were there specific ideas that you can even remember in the early days that everyone was saying that this is not going to work?
Well, yeah, I mean, I think of reasoning as one of the biggest examples of this. Yeah, and the first breakthrough that we launched to the world here was O1, but it wasn't easy to get that off the ground because the world we were living in back then, it was one where pre-training plus post-training, right? That felt like such a promising paradigm.
Yeah.
And so even at a company like OpenAI, you would have people ask naturally, why do something when you have a machine that works? And fundamentally, it's to the credit of, Jakob, Ilya, many of the people who really had conviction and vision in this space, that we started pushing on this in earnest. And even then, it took a lot of steering to get the whole company behind this as a fundamental bet.
Gotcha.
So, yeah.
And how do you kind of develop that ability to motivate researchers? Because I assume that's a big part of, taking a lot of bets and some won't pan out, but still building the trust in the team to know that eventually some of these will actually have, power law effects.
What's really cool about OpenAI is research, it feels like a meritocracy. So oftentimes the research managers are the people who
Do the actual
have done the best research in the past. And so I think a lot of steering can come top down, right? Like if your manager says, hey, I'm like really convinced this is the path forward.
Yeah.
Generally people will take that into heavy consideration, right? It's like, this person who you've respected for their research taste and execution for so long is like now very excited by this idea. It's definitely something that people take into account. So I think there's good top-down steering. At the same time, I think one really cool thing about OpenAI is their bottom-up elements. Like we like to be convinced that that we're wrong, right? And someone can just come with cold hard evidence. And many things like that have turned into core parts of our research roadmap. Just things that no one was really kind of trying to steer, but some researcher on the ground had a heavy conviction in. And that's also a really big delight to see.
Yeah, absolutely. I heard in a recent interview that you gave that your internal research roadmap hasn't really changed, even through all that we've seen, with model development and even other companies. I guess, how often do you guys assess that, reassess that, even like act proactively? I assume it's not a lot of reactive decision making as like other models come out. But how do you like think through that process, especially as everything around you just continues to get better? Yeah.
So I think the thing is, the high level research roadmap should be stable, right? I think people need something to ground in. People need to see a path to what we're building. And I've been very happy that we've stayed the course for a while, but the implementation details can change over time, right? And I think it's important to kind of, like the sequencing will matter, right? The relative resourcing will matter. And the kind of exact bets on the ground will matter. So what we do is, I think we have kind of points in time that force us to reconsider these things. So one example is when we do compute. One of the parts of the job is just figuring out how to allocate compute to projects. And it's a time to kind of question, like, are we really putting compute to use and people to use at the highest priority bets?
And I guess, could you clarify more what you mean by
oil?
Oh yeah, I was like, I'm constantly adding oil. But clarify what you mean by the higher level versus like the more implementation details. Like high level as general as like AGI, that's like our North Star, or is it more like granular than that?
Well, yeah, I mean, at the very highest level, right? We have an org that focuses on pre-training, right? Which is giving models a lot of world knowledge. We focus on RL, like teaching the models how to reason with that knowledge, how to chain the little insights together. And then finally, alignment and post-training, right? And we're always looking at both like how to scale the mainline in each of these domains, and also new bets that fundamentally unlock either like different scaling properties or more aggressive scaling properties.
Gotcha. And so even in that, I heard that every 1 to 2 months you go through what, like 300 projects, like research projects that could be follow through on. Is there a way that you kind of hone that decision making? I assume as you like decide what to actually double down on and what not to, since I assume there's a lot of talented researchers who provide possible ideas
Yeah.
to pursue?
Yeah, so I think really in the spirit of focus. So one narrative you might have heard is, we're really focusing our bets at OpenAI, and we're also trying to do a little bit more directive compute allocation as well. So I don't like micromanaging my managers. I think one important thing is to empower them, but to just kind of give compute, big swaths of compute to the big bets you want to make. And then
that's what you mean by directive, like
But then also give them kind of flexible pools of compute, which they can freely allocate to things that they believe in, or just kind of fudge with the allocations that we prescribe. So I think I think it's just tying, let's say, like a small number of bets, say 3 to 5 bets from each org, into the main research roadmap, and then really letting the managers and org leads take things from there.
Gotcha. Okay, that makes sense. And I guess for rising researchers, so let's say in an interview setting, are there specific tells or ways that you can identify, okay, this person has some potential of becoming a researcher to impact an org in a specific way? Or is it like just looking at the previous research that they've done, and then that is what heavily dictates whether they can actually continue on?
It's a hard problem before someone comes to OpenAI. I think that's genuinely true. I think for a lot of the best research managers, they've worked with so many researchers over time, where you kind of develop an intuition, like the things that they say, the ideas that they bring up. Are those kind of, do they hit the same mark, or like are they the things that you would be thinking about personally too? And so there's this gut check of like, does their intuition match the same intuition that you have? But it is really hard to tell out of the gate. Usually in, let's say 6 months to a year, it's pretty clear who's, has the strongest trajectory and who's going to make a lot of impact. Honestly, I think it's a hard problem, but just having seen a lot of people, go through research development at OpenAI, you develop an intuition for, who's more PP in different areas. And one thing to kind of like just mention there is not every researcher is the same. I think there's a lot of different types of impact. They're the people who just take an idea, it's very clear, and they'll just implement it before anyone else. They're also the people who just come up with the kind of like crazy, almost too crazy, but
moonshot type
but somehow not that crazy, and they really convince you in a different way of seeing the world, or another completely different type of project. So there's a lot of ways to make impact.
No, that's helpful. And so I guess elaborating on that, would you say there's similarities that you would see between, let's say, like top engineers and top researchers? Like I often hear top engineers, even at like small companies and startups, are ones who can take an iota of an idea all the way to production. I assume in research, it's like coming up with the idea all the way to how it's delivered to the end user through like the product. Or do you think it's more so they're focusing solely on the research, not considering like the end design, how it's used by the customer?
Well, I guess the thing about research is many times the path forward is unclear. And so what differentiates researchers is how often they're pointed in the right direction, and how, like you say, taste, right? I think in engineering, there are certain patterns that work. Like, if you want to build a product that looks this way, the engineering principles can be pretty similar. But for research, I think the thing that's slightly different is just this ability to, have good research taste, to convince other people that what you're doing is promising. And then, again, to just kind of integrate it into the core research roadmap.
Gotcha. Great. Okay, it seems like we're done with the vegetables. So now we have to multitask. So we're gonna pour some water into our pots to get the base of the soup going. So in the top right, here. And then just twisting this off. So we'll pour some here. You can use some as well. And while we have this simmer and we'll add the veg, we'll cook our prawns here. So let me clean this up real quick. Looks looking great so far. I feel like saute got some color on the onions and mushrooms. So okay, let's turn this on. I guess one aspect or area that seems very interesting are evals. And more specifically, have there been instances where you've seen like through just vibe checks that it is really good, but on the actual benchmarks it like performs very poorly? Or do you think it's like heavily correlated that, if your Sweetbench Pro is, a high number, then it's like your vibe check on it doing coding tasks is also really, really high?
No. I mean, I think there is this phenomenon. I think internally, I'm not sure if this is a externally used word, but yeah, just like benchmaxing.
Yeah. Good hustle.
I think you can kind of overfit onto certain distributions, and it won't be reflective of how well you generalize, right? Because I mean, easy ways to do this are, you take a benchmark and you just find like very, very, very similar types of instances to the benchmark, and you overtrain on those instances.
Yeah.
So I think beyond that, the other scary thing in the field is the number of canonical gold standard benchmarks is low.
Yeah.
And we really are kind of in an evals crisis, right? Where all the really great evals that we all know, like growing up, like taking the SAT or those are all fully saturated.
Yeah.
And we really need to find good new ways to benchmark the models. I think one great thing about tools like Codex is they've really enabled the fast iteration of evals. Like we're able to just kind of have one person just very quickly put together a very high quality eval. Another kind of interesting thing of just being able to deploy your models is you can just see them evaled as people are doing things with them, right?
Yeah.
One of the great things is, in math and coding and software, like you get a sense for like where they fall over, what the task horizon they can do from this like general, very broad-based deployment. So
Yeah, no, that's helpful. Now we'll just add the prawns to the oil and get some color on it.
Cool.
Yeah, and so I guess double clicking onto that, how do you balance both doing well on these benchmarks, but also not, like benchmark maxing, as you said? Because I assume you want to be most honest and like not kind of cheat the system.
Yep.
But if you have like lower scores, let's say, than a competitor or from other models, to the consumer, maybe like, wait, your scores aren't that great, so the model just probably isn't that good. Like, how do you balance both of those dichotomies?
Yeah, I mean, I think the thing is you just really have to operate over representative mixtures of evals and always invest in creating new evals. And yeah, really just like there's this philosophy of once an eval is out in the world, then it's just already not a good eval. And I think one thing is also just kind of partnering with external organizations to create evals. So, in many of the kind of hard math and science evals, we've partnered with external organizations and they've been able to kind of craft gold standards there for us.
Gotcha.
So yeah, I think there's a kind of interesting philosophy of separate the teams that are creating the evals from the teams that are optimizing
Building,
the models themselves, because that way you don't like co-incentivize them, right? Like
Yeah.
the way the evals team can work is they're trying to build evals that are hard for the model. So there's this inherently adversarial process where you're not kind of cheating yourself, right?
Yeah.
The incentives are somewhat aligned in the right way between the two teams.
Yeah.
Yeah.
And do you kind of also contribute and help in the ideation process or even deciding what evals, you should work with a third party on to develop?
Yeah. So, I mean, I think a lot of the work that Jakob and I do also involves just kind of steering the direction the evals go.
Yeah.
I think we'll notice certain gaps, right? Or certain kind of capabilities that we want. And every capability on the flip side is an eval, right? You need some kind of eval that measures if you've elicited that capability well. So, yeah, I think, it takes a lot of steering, and just to get everyone on the same page with evals is also a lot of tough work.
Yeah. No, that's fair. I guess on Jakub, you said in a previous interview that he's a very funny guy.
Yeah.
Do you have any fun stories that maybe you haven't shared about working with him? Because you also stated that you guys align very well. So your discussions, even on research, are very efficient and help a lot when like driving towards the frontier. I guess like on the opposite side of being very funny, are there things that you can share?
You asked about like a funny story.
Yeah.
Well, he told me this joke yesterday, which I thought was very funny. I mean, in many ways, we kind of jointly manage the research efforts. And, apparently some researcher came up to him and was like, it feels like I now just have an army of, really dumb IOI like gold medalists.
Yeah.
And Jakob was like, that feels like already the situation I'm in in real life. So yeah, no, he's just like brutally sarcastic and funny. Yeah.
No, that's great. It's great to have humor in the workplace, you know, to balance out, especially as you're pushing the frontier on very important work. But that also brings to mind one kind of weird scenario of how models can perform very well on, let's say, the IMO or even on the IOI, but may struggle with some more mundane tasks that a human can easily do. So I guess how do you deal with that?
Yeah. I mean, ultimately, I think what's intuitive for the models is often not that intuitive for the humans. Like there's a lot made of this jagged frontier analogy where there's some things that the model is just inherently, based on maybe the data it sees or kind of the things that we can teach it more easily.
Yeah.
It's just good at. I actually think a lot of it boils down to also just context, right? The models don't have a lot of context that a human has. Vision, of course, is something that's more naturally biologically wired for humans. And so, yeah, I think there's just certain kind of jagged capabilities that models are better at than humans and vice versa. But I also think, context, just being able to take a single task, learn lessons from it, and apply them to future tasks. That capability is something that, a lot of people in AI are working towards right now.
Yeah.
But it's, very natural for humans.
Yeah. And on the context point, a very low-hanging fruit example that many people say is just to increase the context window to provide more examples so the model can perform. But do you think, I assume there's more complexity on how to actually enable, since even with a large context window and a lot of context, there could be bloat or even just a lot of like context rot, as people have said. So how do you go through that process of navigating?
So I think there's kind of the canonical way you would solve for very long horizon learning, which is, you just naively increase your context window, right? And that makes sense. I think there's a difference between implementing long context and implementing long context well, like you said. And there's a lot of kind of like needle in the haystack style evals today to measure that. But I do think beyond that, there are also a lot of, in some sense, like engineering and research shortcuts that you could take. So, like many coding products today have features like compaction, right? Where you can compress kind of either insights or working state. And stuff like that, it just shortcuts a lot of the very brutally difficult and expensive primitives that you have to build with just native long context.
Gotcha. Great. Okay, now we're going to do the fun part. So let's lower the heat a little bit and then add a little bit more oil to the pan. And then we'll torch the shrimp and the prawns to get a little more flavor in there. So I'll first do it on my pan to show you generally what it looks like. But
one-shot learning.
Yeah, indeed. Oh, wait, I didn't pour any bourbon. Okay, wait, so let's pour like a fourth. Okay. And then pour it in, heat is off. And then torch it.
Awesome.
Great.
All right, okay.
I
think I got this.
Okay, so do you want to do it with your,
Yeah.
So pour it to like half of the fourth cup.
Okay.
And then once you have that, I can give this to you.
Perfect.
Great, so it's off. And then once that's off, we can turn it back on. Perfect. Okay. And then now, do you want to hold on this and just press this button to fire it up? Yeah.
Cool.
Yeah. Perfect. Great. Okay. Flambéing it. It's a little light, but yeah. Great. And then we could turn on the heat again.
Okay.
And then we'll just cook off the alcohol.
Okay. Great.
Great. How are you feeling?
Great.
Basically there, cooking everything. So. Okay. Awesome. Yeah, and I guess in terms of research ideas and what to work towards, do you think there's still a lot of low-hanging fruit or ideas that can still be improved a lot through just optimizing small parts of already implemented work? Or do you think right now there has to be a lot of research that are completely new bets that people take?
Yeah, that's a really great question. I feel like there are new bets, but probably not that many. In some sense, like hopefully you feel like, AGI is coming soon, right? And I think everyone sees that these models are getting really capable. And I think if you really imagine the implications of that, we're getting closer and closer to a world where the models can come up with more of the innovations on their own. Right? They can kind of do self-sustained research. This is one of the big org goals that we've set for our research org. And so I think like, what really matters is, are there big bets before that point in time?
Gotcha.
And I think the window is small, but there are still like some fairly significant ideas we're trying out.
Yeah. I mean, there have been some researchers who have stated that to get to AGI, we still need, let's say, like 2 or 3 more breakthroughs. It'd be like continual learning or some other ideas. Do you follow that same view, perspective, or do you think it's kind of more so like not as drastic as coming up with like 3 completely different paradigms in research?
Yeah, I mean, I don't know. I don't know if that same framing, like continual learning is a basic primitive that you have to unlock.
Yeah.
There's so many different techniques. I don't know I think, we're trying a lot of implementations of it. I don't know what would consider as a breakthrough versus not, but I think there are clearly many shots on goal, and I am pretty sure they'll work.
Great.
Yeah.
Okay. Great. Okay. So the shrimp is basically done.
Awesome.
Okay. So do you want to do the flambe thing again to get more color?
Let's do it.
Okay.
Yeah.
Let's turn on the heat a little bit, and then let me get some more oil.
Great.
Yeah, because we want to get like some dark color. I think mine has in here. Great. And then we can hopefully get another shot. Okay. Perfect. Yeah. Do you want to go first?
Same amount of.
Yeah. Same amount. We could hopefully get, because I think the heat wasn't as. Yeah. Okay. So you can put it in. Yeah. And then there you go. Just press a button. Great.
There we
go. There it is.
It's good stress relief.
Yeah. Indeed. And it's like adds some good flavor here. Let me try it over here.
Yep.
Yeah, let's see. Great. All right, let's see. Let's go. Woo! There it is. All right. But we're in the final stretch. We have our shrimp all cooked with some fire. So now we can kind of, cook it off a little bit. And then we should add our veg to the water.
I'm impressed by your multitasking abilities. I think that's actually one thing we need our models to get better at. Like, it should just be able to do some thread like this and also just have a conversation with you. Yeah.
No, I that also reminds me. Do you think images and audio and video and even text that should all be under one model, or do you think it'll like break through like specific specialized like audio model or?
Well, yeah. I mean, I think for a research lab, I think there are a lot of advantages for it to being under one. You just have to maintain one infrastructure stack, for instance. I think the cost of like maintaining and scaling many infrastructure stacks at once, I think that's something that you shouldn't underestimate. So I think there are a lot of benefits to just like, you do some core research in your fundamental stack, and that just carries over to whatever modality or whatever thing you want. So I think there's a strong bias for us to keep it in as few different architectures as possible.
Gotcha.
Yep.
Great. No, that makes a lot of sense. I think like the architecture as well is something that isn't often considered. Yeah. That's very important. But one also term that I've been seeing a lot that you've also kind of mentioned is a vibe researcher. We have vibe coders obviously.
Yeah.
But I guess on vibe researching, what do you think is like the end state? Do you think the main value out of a vibe researcher is just the research taste of coming up with the right idea, or do you think it's more so the execution of going through and following through on the actual research?
So I think we're actually moving towards this world very quickly, right? I think both at OpenAI and at other labs, you're starting to see a lot of the work become mostly orchestration focused, right? Like the researchers coming up with the ideas, and the model's great enough to do the implementation execution by itself. So I think, when it comes down to like, is the value of coming up with ideas versus execution, both are still important, but it does feel like there's this market shift towards just kind of being able to come up with a lot of ideas, and then the model can actually do the execution and orchestration for you. So I think it's very much going to be the future of doing research. We also said earlier, like the models don't quite have the taste yet. And that's why you still need the researchers coming up with the ideas. It's going to be hard to teach the models good taste. We noticed that, but in terms of actually accelerating the research, there's clear tangible benefits already.
Yeah. Do you think there'll ever be parity in terms of research taste with models?
I think so. I mean, when we look at our kind of 3-year roadmap, right? The end goal that we want to reach is one where, the models are just doing end-to-end research, and I think a part of that problem is just being able to have the model come up with good taste. You point at some, just generic benchmark or something, and it finds the right solutions.
Yeah, no, that's helpful. And in terms of research done by humans at OpenAI, how do you guys go about, I guess, the post-mortem process of, let's say, a research bet that didn't turn out well? So I assume that a lot of it is taking these, vast bets and some don't turn out well.
Well, I would say that is a big part of OpenAI's alpha, because I think one thing that differentiates us from other labs is we take a lot of high-risk bets. I think it's what's allowed us to stay at the frontier so consistently over time. But it also means that some of the bets are not going to pan out. Right? And a hard corollary of that is when a bet doesn't pan out, you have to, not delude yourself into thinking that, this is something that will work and kind of disconnect from it. So I think there are certain calls you have to make, right? Like kind of look back and be like, well, this was a promising idea at the time, but actually it's less important than we thought. It's there's some other approach that works better, or there's some other kind of something that we discovered. But I think much of that work is also very fruitful. So what we realize is like even sometimes when people fail at proving out a technique, the write-ups are very important because they'll kind of it'll often be a natural idea. And you can kind of save a lot of people from going through the same pain.
No, that's helpful.
So I guess when it comes to this positive view on failure, how do you balance that with, a researcher, let's say, who takes a lot of bets, consecutive bets, and none of them pan out? Because I assume at a certain point, you'd want a researcher to eventually have contributions that are actually beneficial compared to only taking bets that maybe pan out to being not good taste.
Just through experience, I've definitely seen some people fall into this. But I've also had several cases where, it's just like bet after bet, it doesn't pan out. And just when you're like at the brink of frustration, they have something that's like a mega hit. And this happened enough. So it really just depends on kind of, are the ideas themselves sound? They can be ambitious, but they still have to be sound. And there's a certain kind of person who will just take a lot of those ideas, and it's okay because they're somewhat on the riskier frontier, but they only have to justify it once in a while for it to make sense. Maybe like a very trading like kind of lens on the world, but it's just on expectation, right? Like they need to add value.
No, that's great.
Okay, so we're basically assembled. Now it's the finishing touches. So you can taste your soup, and then we just add soy sauce if it's not salty enough. And if it's too salty, we can add some water. We can lower this down. But let's see our final creation. How is it?
It's pretty good.
Good?
Yeah.
Salty? Okay,
really good.
Mine needs a little bit of water. Could you add some water?
Absolutely.
But great. So how was that? How did that feel?
I think this is student distillation. You're clearly better than I am at this point.
No. I feel like you did a very great job, especially even with the shrimp and flambe. Yeah, it smells great. Wow, okay, that sounds good. I guess just more generally, I'm kind of curious. Are there areas in research or topics that you think are right now overrated and underrated? Like what would you categorize under?
Well, I think if you still have a pre-training is dead view of the world, I think pre-training is definitely not dead. It's underrated. And honestly, I think products and kind of thinking about end uses and how you tie all the primitives you build in research to real agentic use cases in the world, that's also underrated. I think you really can't just kind of build everything in a vacuum and not connect things to utility.
That's great. Awesome. I think we are ready to taste, so do we want to give it a go?
Let's do it.
We can move this, and I think there should be some plating. Do you want to take those plates over here? Okay. Shrimp looks great, but everything else here. Great, and then we could just use these pots. So we have our shrimp. Want to try it? Cheers.
Sure. Cheers.
Let's see. It may be a little sweet. That's a little too sweet because we found way twice.
It's good for me. I have a sweet tooth.
That's good. Okay, great. Sean, do you want to come and taste our tofu soup?
Smells so good, by the way. You guys can't smell it, but
We'll pretend you're a researcher that's trying to get poached, and I'm Zuck, and he's trying to get you. So do you want to grab the spoon over here?
Soup is really going to sway the decision here. The quality of soup.
Yeah. Great.
All right.
Try both.
All right. What was the artistic direction here?
Artistic direction. Well, it was mimicry. I think there's great art in mimicry.
Yeah. Just letting him cook. Good.
Wow. Yeah.
Strong.
I mean, I think one thing I definitely like savory and spice that go together, but then also like the sort of seafoodness.
Yeah.
Kind of really goes into it.
Great. Okay. It's fine.
Am
mine's
I
very
supposed to
dominating.
pick a winner, or what is?
No. You're
what's the
just
deal?
supposed to try it. And
No,
then
you
see
do
if
pick a winner. Yes, you do.
Okay.
This is the evals.
Yes.
Yeah. Swix bench.
External evals.
Okay,
Six bench.
I gotta say, I feel like there's too much water in this. I think like the
I think it's also the pot because this is a big pot.
yeah.
I
Wait.
realize.
Okay. I would say I would have to go for this.
Okay.
Just like you're all respected guests, but I want to be objective.
Of
about
course.
about
Yes.
food. And like the density, I think really a flavor really.
I'll
swings it.
do half the water. Half the water.
Probably.
Okay. Makes a lot of sense.
I mean, I think it's very personal, right? Like,
Yeah, I think it's also very personal. Taste, even we mentioned.
You do a lot of
research
cooking.
Taste.
No. Okay, I know a couple recipes.
Yeah.
I follow them to the T. I can't like if you tell me, oh, cook something slightly different. I'm completely lost.
Right.
Yeah.
He's busy cooking
ChatGPT
the
can tell you.
research.
Yeah. Oh, I'm not gonna lie. I kind of looked up in ChatGPT a couple of things beforehand, like just as prep. But
No worries. But yeah, it was great having you. I feel like you're always leading the field with a lot of research taste as well, and it's
Yeah,
great
appreciate
seeing
you. Yeah.
the work. So hopefully
Absolutely.
it was fun.
yeah,
Thanks
a
for
lot of
coming,
fun.
Mark.
Yeah, thanks so much.